Hi guys, today I'm going to be doing number 12 from chapter 4. Two forces are applied to a car in an effort to move it, as shown in figure P412. A. What is the resultant of these two forces? B. If the car has a mass of 3,000 kilograms, what acceleration does it have? Ignore friction. So this is the figure that we're going to be basing our problem off of. Essentially, there's a car and two different forces, and in part A, we're solving for what the result of these two forces acting upon the car is. So first, we're going to be drawing a diagram of our problem. So first, I have drawn the two forces that they give us from the problem, which are 400 newtons in the right direction and 450 newtons in the left direction. They also tell us that this angle is 30 degrees and this angle is 10 degrees. Side note, please make sure that you label where your positive x and y are, because that will come into play later. Given that we know the magnitude of the forces at the 30-degree angle and the 10-degree angle, we can use both those values to find the x and y components of both forces. So we know that this x component for the first force is 400 sine 30, and we know that the y component is 400 cosine 30. For force 2, we can solve that the x component is 450 sine 10 and the y component is 450 cosine 10. For now, we're going to leave these numbers exact. We're now going to plug the values we just found into a XY chart that has force 1, force 2, and the resultant force. Please note that the x component of force 2 is negative 450 sine 10 newtons because we defined our positive x in this direction, and this force is taking the car into the opposite direction, which makes it negative. After we put our x and y values for both forces, we can find the resultant forces in both the x and y direction by adding these values up. And we end up getting 121.9 newtons in the x direction and 789.6 newtons in the y direction. We're now going to create a new chart to find the total resultant force. Because we know that in the x direction the force is 121.9 newtons and the y direction is 789.6 newtons, we can find the resulting force using Pythagorean theorem because this creates a right triangle. And when we plug in all our values, we end up getting 799 newtons as the resultant force. To find the angle at which our force is going, we can use tangent of this angle equals opposite over adjacent. Once we do that math, we find that the angle is 81.2 degrees. Just to remind you, part B is asking us to find the acceleration if the car has a mass of 3,000 kilograms. To find the acceleration, we're going to use Newton's second law, which states that the sum of all forces equals mass over acceleration. We're then going to manipulate our equation so that we're solving for acceleration, and in the end that is acceleration equals the sum of all forces over mass. When we plug in our numbers, we find that acceleration equals 799 newtons over 3,000 kilograms. And that equals 0.266 newtons over kilograms. Keep in mind that a newton is kilograms times meters over second squared. So then our kilograms cancels and we are left with 0.266 meters over second squared. Thanks for watching, and I hope you now no longer have trouble solving for number 12.